This is a very quick introduction to using TinkerCAD Circuits. TinkerCAD Circuits can be used with boards like an Arduino or a microbit, which are microcontrollers, but it's also useful for electronics wiring without a microcontroller. The first component you need to learn about to use TinkerCAD is the breadboard. This is an essential building block when you're developing circuits. It allows you to connect components and power supplies to produce the functionality you want. The first thing to note is these power rails along the bottom and up here at the top. So you can see they're indicated as red is positive and black is negative. So when we go and we take something like our 9-volt battery and we bring it over here and we line it up and we connect it there, you can see we've got the positive connected to the positive and the negative connected to the negative. What you should know then is once we've done that, all the buttons here, all the holes that you're seeing are showing up, they're connected by green circles. That's showing that they are all connected. So any wire that I plug in here is going to be connected to the positive part of the 9-volt battery. Similarly, if I plug into any of the holes here on the black rail or on the negative rail, that's going to be connecting us to the negative terminal of the battery. Now up here, these two rails are currently not connected. If I wanted to have them available so that they had power as well, I would need to take a wire and run it from there up and plug it in. By doing this, we change that color to red because that's the positive line. So now by doing that, I've connected the top positive rail to the bottom positive rail. But for the moment, I don't need to do that. Another important aspect is that when I move my mouse over each of these groups, you'll see that 5 of the holes get circled in green. That's telling you that all 5 of those are connected, but they're not connected to anything else. So the holes beside them are all separate. They're not connected horizontally, they just connect those 5 vertically. They also don't connect to the other 5 that are on the other side of this gap. And that's very intentional. We often put components that cross this gap, and you'll see that in a moment as we dig into the circuit. So we've got a power supply right now. The next thing we want to do is bring out a switch, because we always have a switch in line with our power supply. And then I think at this point I'll bring out an LED, so we're also going to work with an LED. And I'm going to take this, I'm just going to move it up so it's a little easier to work with the wiring. I've got a power supply, I've got a switch, and I've got an LED. Previous labs we've worked with a light bulb. LEDs are a little bit different in that they only allow current to go through them in one direction. And the current always has to go, the positive connects to the anode and the negative connects to the cathode. So I want to get power going from my positive through my switch into the anode and then back from the cathode to the negative rail. So I'm going to say, okay, I want to connect this down to the positive terminal. By doing that now, you'll notice on this switch, it says that the center post is common. This is terminal 1 and that's terminal 2. This type of switch allows you to direct current in 2 directions. So it can send current from here, from the center, out to the left, or if I flick the switch the other direction, the current will come up here into the common and go out terminal 2 in the right direction. So for the moment, we only have one device. We're just going to kind of use half the switch. So I'm going to run that over. And so now I've got wiring that takes me from the positive terminal up to the common terminal of the switch. When the switch is turned this way, it's going to send current over to the anode. And all we need to do then, logically it seems, would be to take that and run it back to negative. So by doing that, we've got a complete circuit. We've got going from positive through the switch over to the anode of the LED and from the cathode back. It all seems great. However, if I run the simulation up here in the top left, we click the Start Simulation button, and we do that, and it goes boom. It says the current through the LED is 915 milliamps, while absolute maximum should only be 20 milliamps. So we blew up our LED. This is the beauty of emulation. It's really easy to fix. You just stop the simulation and everything's back to normal. So we can't go directly back. What we need to do is we need to limit the current through the LED, and we do that by dropping a resistor in its place. By default, it shows up as a 1K resistor. I'm going to change that to be 500 ohms. I know that'll be a safe value. And then I need to finish the circuit again to go from that part of the resistor back to the rail. So I've got a complete circuit now that goes from the positive terminal up to the common terminal of the switch, from the terminal 1 over to the anode of the LED, and then from the cathode it goes through a resistor and back to the negative rail, which leads us back to the negative terminal of the battery. Now we can run the simulation, and in doing so you can see it came on automatically. If I click the switch, it turns it off, so it limits the flow. Those are the essentials of using TinkerCAD circuits to set up a very, very simple circuit using an LED, a resistor, a switch, and a battery as a power supply.